Here we've got the magnetic field pattern around a bar magnet. One thing to know about these magnetic field patterns is that the closer the lines are to each other, the stronger the field. So if you look at this pattern, the field lines are closest to each other near the poles. So that's where the magnetic field is the strongest. Bar magnets are not the only thing on the magnetic field around them. The Earth has its own magnetic field, which looks a bit like this. And actually, if you look at it very carefully, it looks the same as a magnetic field around a bar magnet, if the magnetic South Pole is where the geographical North Pole was. So this is why a compass placed somewhere or held near the Earth points towards the North Pole. Now we're going to look at magnetic field between two bar magnets. So I'm going to sprinkle some iron filings on this and then give it a tap. And the pattern formed will look a bit like this. Okay, you can see in between the magnets actually quite strong. So this is between the north and south pole of a magnet. Let's try this again, but this time with the same poles. So for example, if I try with the north and north like this, give it a tap. Pattern form looks a bit like this. So you see here, there's not many iron filings in the middle, so the magnetic field is quite weak there. Let's look at the field pattern in a bit more detail. So between the north and south pole of a magnet, the field pattern looks a bit like this. So you can see here it's pointing from north to south, which is what we expect with all magnetic fields. And there's an interesting region in the middle here where the field lines are parallel to each other and they're equally spaced. So here we see the field is quite strong and uniform. Now I know it's quite strong because the field lines here are quite close to each other. So that indicates that the field there is going to be a bit stronger than the other areas. And also the word uniform here means that it's a constant strength. And I can tell this because the field lines are equally spaced, meaning that the strength everywhere in that region is going to be constant, it's going to be the same. Between the north and north pole, the magnetic field pattern looks a bit like this. So again, this is pointing away from the north. Okay, so there isn't a south pole on this diagram for it to point towards, but it's pointing away from the north pole. And in the middle, there's no field lines there. Okay, there's zero magnetic field right in the middle there. That's because the magnetic field from the two magnets is cancelling out. They're adding them with, then they're subtracting, and they're giving a resultant of zero. Same with the south and south pole. The magnetic field pattern looks a bit like this, except now it's pointing towards the south pole. So we can think of it away from the north and towards the south. And again, in the middle, zero magnetic field, because the magnetic field at that point was pointing in opposite direction and was subtracting and cancelling out.